Hi, good evening. कैसे हैं आप? We are going to be talking about haloalkanes, specifically SN1 reactions or elimination reactions. But E2 reactions, don't worry about it. अगर ये SN1, SN2, E1, E2 confusing लगता है तो by the end of this session and next session सब कुछ clear हो जाएगा. हम लोगों ने last session में nucleophilic substitution reaction specifically SN2 देखा था. वहां पे क्या होता था कि there would be a nucleophile. What is a nucleophile? Something that has ज्यादा electrons है, वो देना चाहता है electrons को. That attacks, well, some sort of a, what is it attacking? It attacks a compound here, right? And it forms a haloalkane. That's what is happening. The mechanism there, remember, the number 2 was talking about kinetics, मतलब कि second order reaction था और वहां nucleophile की concentration as well as the substrate दोनों की concentration matter करती थी. अब वो substrate could be an alkane or काफी other time route substitution मतलब कि alcohol होता था. We saw many such examples. आज हम लोग बात करने वाले हैं दूसरे टाइप के सब्स्टिट्यूशन रिएक्शन यानी कि SN1 रिएक्शंस की. SN1 मतलब 1 हो गया ऑर्डर. ऑर्डर, राइट? रिमेंबर द इजी वे रिमेंबर दिस इज कि जो नंबर है 1 या 2 दैट टेल्स यू अबाउट द किनेटिक्स, जो रियल लाइफ चीजें हैं जो केमिस्ट को जरूरत पड़ेगी. आई नो यू आर थिंकिंग अरे बट वो तो वन स्टेप रिएक्शन का SN2, ये है टू स्टेप रिएक्शन. विल लुक एट ऑल ऑफ दैट. द नंबर ऑफ स्टेप्स decided by kinetics and thermodynamics. Revising what we did in the last session. SN2 मतलब बहुत जल्दी रिएक्शन आता है, न्यूक्लियोफाइल तुरंत आके अटैक कर लेता है. ठीक है, दैट्स अ वन स्टेप रिएक्शन. ठीक है, अब हम लोग SN1 के बारे में बात करेंगे. हाय आस्तिक, हाउ यू डूइंग? गुड इवनिंग, गुड टू सी यू हियर. ओके, सो पहला एक छोटा सवाल देखते हैं. अ क्वेश्चन फ्रॉम लास्ट टाइम, या थिंग्स दैट वी डिड लास्ट टाइम. ओके, इनमें से कौन सा एम्बिडेंट न्यूक्लियोफाइल है? व्हाट इज द न्यूक्लियोफाइल, व्हाट्स अ बेस? वो सब हमने बेसिक चीजें कवर की थी. न्यूक्लियोफाइल और बेस में फर्क क्या होता है? कैन यू गाइस हेल्प मी विद दिस वन? इन दिस केस एम्बिडेंट की बात कर रहे हैं. एम्बिडेंट मतलब दो ऐसे प्लेसेस हैं जहां से इलेक्ट्रॉन्स निकल सकते हैं. ओके, सो वेयर डू यू सी टू प्लेसेस वेयर इलेक्ट्रॉन्स आर देयर? यहाँ पे आई सी इलेक्ट्रॉन्स जस्ट ओवर हियर. not so much this. इसमें तो एक ही है, तो nothing. It must be this. You've got a couple here and oxygen. What is the structure of NO2 minus? किसी को मालूम है क्या NO2 minus का structure क्या है? Is it like, where is the negative charge? Is it ONO or is it something else? Well, whatever you do, it's still gonna look like ONO, right? Nitrogen is central atom, दो oxygen बने हुए हैं. Okay, ठीक है. Maybe one has a double bond, one has a single bond, and this has the electron on top. Maybe ऐसा है क्या? Is this how it looks like? O and nitrate ion. Okay, all right. अरे वाह, गुड स्कोर राम, गुड स्कोर, ग्रेट स्कोर. देखो, आप जो भी बीच में टेस्ट ले लो ना राम, it's not the full syllabus test, so don't worry about it. These are all learning experiences. Nitro N, that's very nice. Nitro N, nitrito O. Bonding किससे होती है? Normally, when we talk about, thank you Ram for pointing that out. He's saying something called nitro N. ये क्या चीज है? ये हम लोग कोऑर्डिनेशन कंपाउंड में देखेंगे कि दो तरीके से यहाँ पे चीजें हो सकती हैं. ठीक है, जस्ट काउंट कर लो नंबर ऑफ इलेक्ट्रॉन्स. ठीक है ना, 6 और 2 8, 4 5 6 7 8. ओके, कूल. तो यहाँ पे नाइट्रोजन ऑक्सीजन दोनों से इलेक्ट्रॉन्स हैं दैट कैन बेसिकली अटैक थिंग्स. सो दैट्स व्हाई दैट शुड बी द आंसर. ओके, गुड जॉब, गुड जॉब. नेक्स्ट वन. इनमें से कौन से हम लोग सब्सटेंस को यूज कर सकते हैं एज अ सॉल्वेंट इन SN2 रिएक्शंस? रिमेंबर, एक तो था न्यूक्लियोफाइल, दूसरा था सबस्ट्रेट, तीसरी चीज सॉल्वेंट भी जरूरी है. सॉल्वेंट ऐसा होना चाहिए जो न्यूक्लियोफाइल को अच्छी तरह से सॉल्वेट न करे, मतलब फ्रीली मूव करने दे. अगर हमारे पास पोलर प्रोटिक सॉल्वेंट हुआ, दैट्स बैड. इफ इट डज नॉट हैव अ प्रोटॉन, दैट्स गुड. सो ए प्रोटिक सॉल्वेंट इज व्हाट वी आर लुकिंग फॉर. क्योंकि अगर प्रोटिक सॉल्वेंट होगा, न्यूक्लियोफाइल जिसके पास इलेक्ट्रॉन है वो हाइड्रोजन बोला कि भाई मुझे दे दो इलेक्ट्रॉन. प्रोटिक मतलब हाइड्रोजन, राइट? सो वी वांट ए प्रोटिक सॉल्वेंट. दैट्स व्हाट इज गुड फॉर SN2 रिएक्शन, बिकॉज न्यूक्लियोफाइल जो है फ्रीली मूव कर सकता है. DMSO एक था. I don't know why I keep writing B. Yeah, dimethyl. Dimethyl क्या था? Sulfur oxide. Anyway, it's a lot like carbon, like a ketone. But this, if you remember from last session. So ये हट गया, ये हट गया, ये हट गया. Only possible answer is this. Why is ammonia? Ammonia क्यों हट गया? यार, ammonia has hydrogens. Okay, cool. So क्या बोलते हैं? This is called furan. Okay, cool. Let's go. Tetrahydrofuran. THF. Furan. What is furan? This is furan. This is THF, tetrahydrofuran. All right, good. Let's go. इसमें से आप इस तरफ इन कंपाउंड्स को अरेंज कर सकते हैं इन अ रिएक्टिविटी ऑर्डर towards SN2 reactions. Can we do that? Okay. SN2 रिएक्शन, SN2 रिएक्शन मतलब जो सबस्ट्रेट है वो बल्कि नहीं हो तो अच्छी बात है, अगर बल्कि है तो प्रॉब्लमैटिक है। बल्कि 1 bromo 3 methyl, 2 bromo 3 methyl. Okay, let's draw this. What is this? 1 bromo 3 methyl butane. ब्यूटेन पहले ड्रॉ कर लिया, ब्यूटेन ड्रॉ कर लिया, ब्यूटेन ड्रॉ कर लिया। ओके, 1 bromo 3 methyl, 1 2 3 मिथाइल, अच्छा ठीक है। 1 ब्रोमो था, ये तो 2 ब्रोमो गलती से बना दिया। 1 ब्रोमो, ओके कूल। 2 ब्रोमो 3 मिथाइल एंड 2 ब्रोमो 2 मिथाइल। ये मुझे सबसे क्राउडेड लग रहा है, राइट? दिस इज द मोस्ट क्राउडेड, ओके। बट व्हाट इज दिस? इज दिस द सबस्ट्रेट और इज दिस द न्यूक्लियोफाइल? क्या है ये? I think this must be a substrate, right? So we're going to look at probably not this. This is going to be the least मेरे हिसाब से, right? This is going to be the least. And सबसे ज़्यादा होगा ये because this is a primary carbon, this is a secondary carbon, this is a tertiary carbon. Tertiary carbon, bulky and all of that. So this should be the order. मेरे हिसाब से order होना चाहिए. If you don't agree with this or have a different idea, please मुझे chat में बताओ and I'll help you figure out how that works. Okay. एक और सवाल लेते हैं. Just to cement all the ideas we have learned last class में. इनमें से कौन सा है करेक्ट ऑर्डर ऑफ डिक्रीजिंग SN2 रिएक्टिविटी? सिमिलर क्वेश्चन, एक्चुअली एग्जैक्टली सेम सवाल है, राइट? मैंने आपको उसमें आंसर बताया तो यहाँ पे पता चल गया कि अगर R3C मतलब टर्शरी हो गया, ये हो गया सेकेंडरी, ये हो गया प्राइमरी, हेंस दिस इज द आंसर, प्राइमरी रिटर्न सेकेंडरी रिटर्न टर्शरी। इट्स एग्जैक्टली द सेम, दो दैट दिस क्वेश्चन इज एग्जैक्टली सेम एज बिफोर, बट पिछले में थोड़ा बहुत हम लोग को देखना पड़ रहा था। दिस क्वेश्चन इज फ्रॉम AIPMT, आई थिंक 2002 या कुछ था। सो देखो, every question we are doing is relevant to you, whether you're going to give JEE main या फिर AIPM, sorry, NEET or even JEE advanced. JEE advanced का बस ये है कि सवाल सॉल्विंग के तरीके अलग होते हैं. There are many concepts involved. If you're interested in the JEE advanced thing, check out the other channel. Yeah, I've done sessions there, revision sessions around October, November last year. Check those out. खैर, JEE main NEET के लिए we are good. We're right on track. This is a nice question. This is a very lovely question. Okay, check this out. इसमें से मेजर प्रोडक्ट्स क्या होंगे? RX plus KCN, RX plus AgCN. अब ये बहुत ही इंट्रिगिंग क्वेश्चन है बिकॉज यू नीड टू अंडरस्टैंड केमिकल बॉन्डिंग प्रॉपर्ली टू बी एबल टू डू दिस. ओके, व्हाट डू आई मीन? मैंने अभी बताया था किस टाइप की बॉन्डिंग होती है. नाउ कैन यू हेल्प मी विद दिस प्लीज, पीपल ऑन द चैट? मेजर प्रोडक्ट्स इसमें से क्या होंगे? RX plus KCN, ठीक है? दिस इज जस्ट K plus and CN माइनस. माइनस किस चीज पे? लेट्स अज्यूम इट्स C पे, राइट? नॉट, इट्स नॉट आइसोसाइनाइड, वी आर अज्यूमिंग इट इज साइनाइड, ठीक है? बिकॉज CN लिखा, अगर NC लिखा होता देन दैट वुड बी आइसोसाइनाइड. So we're not doing that. This is cyanide, not isocyanide. Okay, great. So K plus CN minus 1 gaya RCN. Okay, good. What about this? RX and AgCN. How does this bond break? If you remember Fajan's rules, Ag plus is pretty big. It's not that great. Fajan's rules है, अगर बड़ा सा cation आ गया तो it's what do you think is going to happen here? Is this a covalent bond between silver and CN? Have you heard of that at all? What is Fajan's rules? किसी को याद है? What are Fajan's rules? Does anybody remember what Fajan's rules are? I am to do that on, in fact, parso on the JEE channel. I'm also going to be talking about this. So that's very interesting. So I've got low positive charge, check, single positive charge. Okay. दूसरी चीज क्या है? दूसरी चीज है कि large cation, check. Small anion, well, not really. It's not that small, but ठीक है. I'm just going to put like a maybe. Okay, cool. So what is happening here? Is this going to be an ionic bond or this thing? Okay. Low positive charge is this. Both of these make it look like it's going to be ionic bond. तो किस type का bond है? Small cation, high charge, large anion, large polarizability. राम ने जो चीजें बोली हैं, okay, those talk about that's talking about a covalent bond. Okay, ठीक है. अगर covalent bond है तो you got to have a large anion and which increases polarizability. अगर ये चीजें याद है तो ठीक है. Okay, cool, great. That's interesting. So what do we do now? हम लोग अभी क्या करें? What kind of bond is this? Silver और C के बीच में bond क्या है? If you don't remember that, please go revisit Fajan's rules. But this is basically a covalent bond, which means it's not likely that this. And also, by the way, one more thing. This guy has electrons, does it? Yeah, it has electrons. It has a couple of electrons. Like, yeah, okay, I'll give those away. I'll form that bond. So this goes, this forms this, which is interesting, isn't it? ठीक है। अब वही चीज जो मैंने आपको ONO के बारे में बताई थी, बेसिकली नाइट्रो ग्रुप. If you do RX and KNO2, this is going to form, and I'm going to give you the hint here because this is beyond JEE main or NEET. Okay, this is more towards advanced and AIMS as it used to be. So I'm just going to tell you here. This is going to form RONO, and for that same reason कि देखो AG already इससे bonded है, oxygen से bonded है, ठीक है. तो nitrogen is free to form the bond, and this forms RNO2, which is interesting. ठीक है. So the bonding in KNO2, yeah, जैसे मैंने बताया था, if you do this, if you write it like this negative charge and a positive charge. So that's all this is. Okay. So couple of interesting questions. Okay, let's start. काफी सवाल हो गए. I don't want to throw you off by giving you too many questions that are above the level of whatever exam you are preparing for. अगर आपको तैयारी ठीक से करनी है, एनसीईआरटी के सारे सवाल करिए, इंक्लूडिंग सॉल्ट एग्जाम्पल्स एंड एग्जाम्पलर सवाल भी कर लीजिए. इवन फॉर नीट इट्स ओके, एक्स्ट्रा प्रैक्टिस के लिए. पीवाईक्यूज तो है ही, बट बिसाइड्स दिस डू दैट. ऑलराइट, कूल. Let's get back to nucleophilic substitution reactions. SN2 cover कर चुके हैं. Let's look at this now. Look at this. Oops. ATH, huh? What's that about? Now the number 1 and the number 2 are talking about kinetics. बार बार मैं यही बता रहा हूं. This is talking about the order. And SN1 में ये स्पेशलिटी है. SN1 में ये स्पेशलिटी है कि टर्शरी कार्बन के लिए this is the mechanism that's preferred. Okay, prefers this. अब वो मैकेनिज्म क्या है, क्यों है, हम लोग देखेंगे. अगर आपको हाइड्रोकार्बन, JOC वो सब याद है, you remember, you may have an idea that if this were to break, right, and form a positive ion, so R1, R2, R3, and let's put a plus over here, and this is very stable as compared to secondary, as compared to primary, right? So अगर मैं किसी चीज को बहुत टाइम दे दूं, I give it enough time in life, thermodynamically speaking सबसे स्टेबल होगा ये. ठीक है. So we say that SN1 reactions are thermodynamically limited, मतलब you have enough time. Time is not a concern. Remember, SN2 was यहाँ पे जल्दी से तुरंत रिएक्शन हो जाता था, इसलिए न्यूक्लियोफाइल had to attack very quickly. Okay, cool. Because of this, it only depends on the substrate and nothing else, the concentration. ठीक है. You will see that rate is going to be proportional. आगे देखेंगे हम लोग, बट अभी बता दे रहा हूँ सबस्ट्रेट सिर्फ. Not really the nucleophile. Doesn't matter कौन सी nucleophile. ठीक है. मैकेनिज्म क्या होता है, मैंने आपको हिंट बता ही दिया है. मैकेनिज्म ये है कि इलेक्ट्रॉन्स ये भाई साहब ले लेते हैं, ठीक है, कार्बोकैटायन बन जाता है, which means कि something takes electrons away from the carbon, and the next step is the attack of nucleophile. This is a fast step. This is a slow step. मैं बताया था ना, enough time, give it enough time. एनर्जी है, एनर्जी द फोकस टू लोअर एनर्जी. It's a slow step, fast step. अब किनेटिक्स के हिसाब से दिस इज अ कॉम्प्लेक्स रिएक्शन, एक स्टेप में नहीं हो रहा है. सो समवन में आस्क यू दिस क्वेश्चन कि एलिमेंट्री है कि नहीं. वो SN2 वी कैन से एलिमेंट्री है, कैन से, बी केयरफुल दो, थोड़ा दैट्स अ लिटिल कॉम्प्लिकेटेड फ्रॉम द ट्रांजिशन स्टेट, बट दिस इज डेफिनेटली नॉट, लाइक दिस इज डेफिनेटली नॉट an elementary reaction, it's a complex reaction. Good leaving group, Ram says good leaving group. Okay, cool, sure. Interestingly, whether here or there, दोनों जगह leaving group की एबिलिटी वही है कि आयोडीन greater than bromine greater than chlorine. We'll look at that. But since Ram pointed out, yes, rate determining step is formation of carbocation. Yes, सबसे slowest step is the rate determining step. और यहीं पे यहाँ लिखा है सबसे this is slow, which means कि अगर मैं उल्टे डायरेक्शन में थोड़ा सा पानी डाल दूँ, उसको just gonna go and form this compound once again. Okay, so it's a slow step. This is the leaving group. Okay, as Ram pointed out in the chat. इसको हम लोग leave कर जा रहे हैं तो उसको leaving group बोलते हैं, same as before. Okay. Now here बात करेंगे सॉल्वेंट की, बट व्हाट वुड बी गुड फॉर दिस? व्हाट डू यू थिंक? इफ देयर इज समथिंग दैट सराउंड्स दीस आयन एंड डजंट लेट देम कम बैक टुगेदर, दैट्स अ गुड थिंग. सो हियर वी विल यूज अ पोलर प्रोटेक सॉल्वेंट. क्यों? क्योंकि ये इसको अच्छी तरह से आयोनाइज करेगा. वाटर मॉलिक्यूल्स will surround both of these ions, it will keep them happy, stopping them from recombining. This is a double head arrow, मतलब equilibrium. Okay, that's why that's there. So कोई भी कुछ भी मग करने वाली चीज नहीं है, it's all logic. Okay, so now if I have somehow made this stable, ये बन गया, उसमें nucleophile attack करता है, what happens? Water, you can just use water as a nucleophile. Yeah, if you're trying to form what? OH. This is a fast step. अब ये क्या हो गया, ये तो OH नहीं लग रहा है. हाँ ठीक है, ये चला जाएगा. This will go away. With what? ये H+ क्यों चला जाएगा? Because plus charge on oxygen, electronegative atoms, not stable. ठीक है. And also you have a Br- hanging around. You're like, hey, absolutely, let's go then form this. ठीक है, yeah, you can write H plus H2O plus also. वही है, same चीज है, ठीक है. This is the first step. So if you have this sort of a thing, this is the 3D way of looking at the same thing. Yeah, very very bulky group, but give it enough time and this breaks and it forms this awesome carbocation. Now this carbocation then gets attacked by the nucleophile. It is पानी में ही तो है, पानी is polar and it is protic, right? Polar है, protic है. तो वहां पे आया water molecule and oxygen goes to that negative charge and there's a bond that gets formed. Beautiful animation. So 2 steps, right? This is the fast step. I know it doesn't look like it's the fast step, but it is. Okay, in reality it is. पहला वाला slow था and this is the final product that you get. But there's a plus charge over here, it's not very stable, so another water molecule comes, takes that H away. H3O plus बन जाता है. So H3O plus along with Br minus gives you HBr, वापस acid बन जाता है. Final product, alcohol. Next chapter we're going to study, by the way, after haloalkanes is going to be alcohol phenol ethers. So hey, we're studying a bit of that as well. ठीक है. It's unimolecular. इसका क्या मतलब हुआ? Characteristic में लिखा है, मतलब the order is 1. We're talking about order. Remember, SN1, 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 SN2, E1, E2. वहाँ पे हम as somebody who's a person who does stuff in the lab, you would only care about the kinetics. You don't care कितने steps में हो रहा है. हमको क्या मालूम, एक step, 2 step. ठीक है, that's cool. That's good to ask questions on. But realistically speaking, I only care about concentration, which means order. ठीक है. ये कार्बोकेटायन इंटरमीडिएट बनता है. So rearrangement is possible. What do you mean by rearrangement? देखो, मैं किसी चीज को बहुत टाइम दे रहा हूँ. So lowest energy, most stable. Somehow, अगर सेकेंडरी कवर बना है, किसी तरह टर्शरी बन सकता है, मे बी इट हैपन. समटाइम्स और भी अजीब चीजें हो जाती है, कभी कभी रिंग भी बन सकता है. एंड जेई एडवांस और जेई मेन में यही फर्क है. जेई एडवांस में एक बार सवाल ऐसा आया था कि इंस्टेड ऑफ रेगुलर ग्रेनाड रिएजेंट वाला रिएक्शन कुछ और हो रहा था, रिंग क्लोजर हो रहा था, कुछ हो रहा था. भी एक स्टूडेंट डिस्कॉर्ड पे पूछा था, राइट? So this is where you have to be careful. Rearrangement is possible, okay, in SN1 reactions to get to the most stable thermodynamically stable state. ठीक है, cool. What are you guys talking about? What do you want me to repeat, dude? Rishant, come on to the Discord channel. We'll talk about things that are not related to what I'm talking about here. Discord, Telegram, come anywhere. If I have not given you the link, just give me a second. I'll give you the link and you can talk about it right over there. There are some awesome bunch of students. There are around 700 of them. Around 30, 40 of them are very active. And yeah, they help you with stuff in life and doubts, obviously. Physics, chemistry, maths, bio, जो भी तुम्हारे डाउट्स है आके पूछ लो डिस्कॉर्ड पे, टेलीग्राम पे. मुख्तियार, क्या फिर से रिपीट करना है प्लीज? You have to explain, right? If there's something you want me to repeat, you gotta pipe in. So, जैसे मैं बोल रहा था, because there's enough time, and the rate determining step में न्यूक्लियोफाइल है ही नहीं. Rate determining step है जहाँ पे कार्बोकेटायन बन रहा है. So, SN1 reaction is independent of the concentration and also nature of nucleophile. It doesn't care. Pretty interesting, pretty interesting. So you only care about tertiary, primary, secondary. Hey, hold on. Tertiary के भी ज़्यादा stable क्या होता है? Benzyl resonance कहीं पे हो रहा है. Okay, that's even more stable. So keep this in mind. Don't always monkey tertiary is the best. Benzyl carbocation can also be, more stable. That's where we talk about JEE advanced or harder questions from JEE main or NEET. Those 35 to 50 जो NEET में आते हैं ना, section B के 36 to 50. So rate is only dependent on the substrate. It says alkyl halide over here, but I'm just going to go ahead and say substrate. ठीक है? Well, let's call it substrate. कोई भी substrate हो सकता है. ठीक है? पहला step slow है और rate determining step है. Rate determining step का मतलब क्या होता है? ठीक है? जो सबसे slow step है. अगर that's a good way to remember this is this कि अगर जो है पहला जो है opening narrow है, right? तो बाकी openings अगर जितनी भी broad हो, it does not matter, right? जितना जो narrowest step है उसका ही वो डिसाइड करेगा वो कितनी जल्दी यहाँ से सैंड नीचे जा रहा है. So this right here is going to be my rate determining step. This is the general idea. We've done this in kinetics in detail. Yeah, so the large opening, narrow openings. This is the one that decides it because that's the slowest step. ठीक है? Anyway, cool. This is a bit of a repetition. I don't know बार-बार क्यों चल रहा है. भाई साहब आगे भी तो बढ़े. 3 बार चल चुके आप. ठीक है, cool. What are the factors that affect SN1? We've already spoken about them. But we'll formally उसके बारे में बात करेंगे. Nature of alkyl halide. Now in this case, if I have a tertiary carbon, more stable. Secondary than primary. Carbocation stability. And obviously benzyl carbocation is more stable. ठीक है? And this is going to be the least. If you want to know the actual order, look at this. These numbers are not in your NCERT anywhere, but it's okay. देखो, look at the primary almost does not happen. Like this is, look at that, just relative numbers. ठीक है? You're like, why did it take this to be 0? I could have taken one of these to be 1, and then, but look at how big that number is. Okay, that's why there was no 1 as such. So secondary फिर भी हो सकता है, it could go either way, it could go SN1 or SN2, but tertiary always goes through SN1 if the reaction is going to happen at all. This is the relative rate of all of these. Cool. So with that in mind, can you answer this question just to make sure, Mukhtiar ji, if you are awake, Rishant, if you are interested in what we're talking about, Ram, Astik, anybody else who's watching this live, how do you solve this question? सबसे fastest SN1 reaction किस चीज का होगा? Fastest, हम लोग तो बोल रहे थे we don't care about time. अरे ठीक है, we don't care about time, but relative rate दिया था ना, अभी पहले ही तो देखा, अभी दिखाया था relative rate. ठीक है, देखो मैं दो चीजें बोल रहा हूँ. This is thermodynamic stable, मतलब you give it enough time. But even in that, जो स्लो स्टेप है उसका भी तो कुछ टाइम का कॉन्सेप्ट होगा ना. एक तो बहुत स्लो हो सकता है, देखो रस्टिंग ऑफ आयरन इज स्लो. व्हाट इज स्लोअर? फॉर्मिंग ऑफ पेट्रोलियम, राइट? और रेडियो एक्टिविटी ऑफ कार्बन 14 5000 इयर्स समथिंग. सो स्लो के भी ऑर्डर्स होते हैं. इट्स ऑल रिलेटिव. सो सबसे फास्टेस्ट SN1 रिएक्शन कौन सा होगा? मेरे हिसाब से द आंसर इज वेरी सिंपल. दिस इज नॉट अ कॉम्प्लिकेटेड क्वेश्चन एट ऑल. या राम एब्सोल्युटली राइट. इट्स डी, बिकॉज टर्शरी ये है. Yeah, so this should be the answer. Yeah, absolutely. And what do we have here? This is secondary, this is primary, and this is just alkyl, right? So ये सबसे कम होगा. So in fact, if you were to put the order here, D, C, P, and A, this would be the right order. All right, sweet. Let's move on. अब इनमें से सबसे तेज कौन सा होगा? What if I form rings? Remember, there are no benzene rings here. This is just a cyclohexane. This is just cyclohexane with some more things. इनमें सबसे तेज कौन सा होगा? What do you think? Does it change anything for you guys? कुछ बदलता है? कुछ बदल रहा है यहाँ पे? Let's see. ये मुझे सेकेंडरी दिख रहा है सबसे क्लियर. ये प्राइमरी दिख रहा है. नहीं, होल्ड ऑन. ये भी सेकेंडरी है. अच्छा, ये दोनों सेकेंडरी दिख रहे हैं. इंटरेस्टिंग. एंड ऑल्सो ए इज प्राइमरी एंड ये तो टर्शरी है. तो ये तो सबसे ऑब्वियस लग रहा है. है ना? What do you think? अगर ये this should be the most obvious, but there's something interesting that happens here as well. इस वाले में, I think. I mean, what you let me know. B, Ram says B. What about C? C में अगर मैं यहाँ पे प्लस चार्ज बनाऊँ, say theoretically, let me put a plus charge over here. Now, what happens here? Is it possible कि यहाँ पे जो एक हाइड्रोजन है, वो भाई साहब ऐसे टूट जाए और बन जाए हाइड्राइड, और ये इधर आ जाए. इस चीज को हम लोग हाइड्राइड शिफ्ट बोलते हैं. इज दैट अ पॉसिबिलिटी? व्हाट डू यू थिंक? इज दैट अ पॉसिबिलिटी? आई डोंट नो, आई एम आस्किंग यू. परहैप्स, मे बी, बट इवन इन दैट केस बी इज स्टिल फास्टर. ठीक है, बिकॉज बी में ऑलरेडी टर्शरी बना हुआ है. इसमें एक हॉप स्किप एंड जंप है. परहैप्स दिस इज पॉसिबल. कीप दिस इन माइंड. इसको भूलना मत. कीप दिस इन माइंड. बी इज द राइट आंसर. ठीक है. नेचर ऑफ इलेक्ट्रोफाइल. इलेक्ट्रोफाइल मतलब इलेक्ट्रोफाइल. ओह, सबस्ट्रेट. इलेक्ट्रोफाइल, बड़े बड़े शब्द. तो सबस्ट्रेट हो गया ना. एक मिनट. ओह, न्यूक्लियोफाइल लिखा. आई डोंट नो व्हाई आई वाज सेइंग इलेक्ट्रोफाइल. दिस वाज सबस्ट्रेट, इलेक्ट्रोफाइल. ठीक है, बोथ ऑफ दीज शब्द आर सेम फॉर दिस. ओके. नेचर ऑफ न्यूक्लियोफाइल. न्यूक्लियोफाइल, वेल, न्यूक्लियोफाइल का क्या है कि जल्दी से अटैक करे, छोटा हो. दीज आर टू थिंग्स. ओके. इफ इट इज, और what else? Nucleophile. But actually nucleophile doesn't matter, no? Hold on. Rate पे तो फर्क नहीं पड़ता है. It's unaffected by the concentration. So the whole goal is that if it gets nicely solvated, that's good. मतलब कि अगर कोई वीक सा न्यूक्लियोफाइल है तो बेस्ट है. न्यूट्रल न्यूक्लियोफाइल. क्यों? कि अगर वीक नहीं हुआ, what happens if you take a strong nucleophile, or if you take a base like a OH minus or something? अगर ये ले, like if I take NaOH, what happens then? What do you think? अगर मैं NaOH ले लूं तो क्या हो जाएगा? Well, any ideas? What happens if I take a strong nucleophile? Well, this is not a strong nucleophile. This is a strong base. Strong nucleophile क्या होगा? Any idea what's a strong nucleophile? Tick tick 1, tick tick 2. Say RO minus. What about this? Oh, that's a strong nucleophile and a much stronger base as well. क्या फर्क पड़ता है? फर्क क्या पड़ता है? I'm saying confidently, भाई, it doesn't matter. It doesn't matter. सिंपल चीज, अगर आप सिर्फ पानी डाल दो, right? Just put water. That's a very weak. पानी, it's just water. It's got nothing. It's not going to split up into OH minus and H plus. बहुत कम quantity होता है, right? 10 power minus 7, you know already. So अगर पानी है, that also makes the reaction happen. That's what I mean by weak or a neutral this thing. And I can also take ethanol, but not ethanol plus NaOH. Not this. Not this. That makes it very strong. But why? उससे क्या फर्क पड़ रहा है? What is the big deal? We'll look at that. When we look at nature of solvent, we'll look at that. Okay. What do we want in the solvent? We want the solvent to be able to make these two things stable, as I told you. Which two things? The cation and the anion. How do you make them stable? हमने देखा ना, यहाँ पे कुछ solvolysis, hydrolysis लिखा हुआ था. A polar protic solvent will greatly increase the carbocation formation, क्योंकि वो surround कर देगा उसको with something that has a slightly negative charge or has some electrons, right? So that will stabilize the cation. Similarly, anion को क्या stabilize करेगा? Anion को stabilize करेगा something with a positive charge or something that has hydrogens. So polar protic, polarity होनी चाहिए और hydrogen होना चाहिए. That's generally a good thing. So just take something as simple as water. This solvent is happy, so it doesn't allow it to react back to form the original substrate. ठीक है? All right, sweet. Lastly, leaving group ability, जो Ram already pointed out कर चुका है, is the same as before. Yeah, अगर कोई चीज है जिसमें negative charge आसानी से हो जाता है, तो that's good. So large things are easier, just like before. So what is common between SN1 and SN2 is this. I want to write that here. Common between SN1 and SN2. Now, the interesting thing here is because carbocation बनता है. What is the hybridization of a carbocation? Carbocation होता क्या है? What is a carbocation anyway? Okay, I've got C. Let's take carbocation. मतलब कि if I had some bond over here, let's take okay ठीक है X and इसके electrons चले जाते हैं. अच्छा, अगर electron चले गए तो let's assume कि initially it was sp3. Okay, after it forms this plus charge का मतलब क्या है? Plus charge का मतलब ये है becomes sp2. Oh, planar. That's interesting. And it has an unhybridized p orbital. You know this from 11th grade. I hope so. Yeah, this is important and basic stuff. Carbocation का मतलब क्या है? Unhybridized p orbital, that's empty. ठीक है? With all this in mind, p मतलब px, pyz, pz कोई भी हो सकता है. pz is usually internuclear axis, etc. तो सब तुमने पढ़ा है bonding में. ठीक है? So now that I've got a planar carbocation, तो the attack of the nucleophile could be from this side or from the other side. If this is the plane, like ये है plane, मैं इसको ऐसे turn कर रहा हूँ, so इस तरफ या फिर इस तरफ, दोनों तरफ से आ सकता है. But no, there's no buts. I mean, like that's it. That's all. So what you get theoretically is a racemic mixture. मतलब अगर chiral carbon है तो obviously all this only arises if you have a chiral carbon. If you don't have a chiral carbon, it doesn't matter. Doesn't matter. ठीक है. So यही लिखा है यहाँ पे अंग्रेजी में. Nucleophile can attack on the carbocation from either face. If reactant is chiral, then attack of nucleophile from both faces gives enantiomers as the product, which is called racemization. बड़े बड़े अंग्रेजी के शब्द. ठीक है. See, now this again shows the unhybridized empty p orbital जिसके बारे में अभी तक बात कर रहा था. What? This right here. ठीक है. तो या तो ऊपर या तो नीचे से. This is the plane of carbocation. Now, I know I'm going into a lot of detail, but this is all you need, bro. Like, if you understand all of this, you're going to literally ace any question on all of this, either whether it's JEE main or NEET or any other exam that you're going to be writing. All right, cool. So, अगर ये भाई साहब गए ऊपर से है तो डिटेंशन कॉन्फ़िगरेशन, अगर ये है तो उल्टा हो जाएगा. What is configuration? There's a concept of RNS. You give things priority and all of that. It's not in your syllabus per se, but if you want to read up on this, read up on RS configuration. ठीक है? And it's definitely not in the syllabus of JEE Main, NEET, or even JEE Advanced. I'm going to write that down, but if you're interested, go ahead and read it. Okay. Yeah. All right. This configuration लिखा ना, inversion of configuration मतलब क्या है? ठीक है. And in the end, you get a racemic mixture. What's up, Deepka? So, here's the catch. Exceptions. Chemistry all about exceptions. थोड़ा सा inverted product ज़्यादा मिलता है. Just a slightly higher proportion of inverted product मिलता है. ठीक है. I know it's supposed to be just this. It's supposed to form a planar carbocation. It has an unhybridized P empty. Let's make it nicely and neatly. थोड़ा सा. One more time. Infinity sign. Another greater than. Empty orbital. Right? एक है यहाँ पे. तो किसी तरह से भी आ सकता है. this way, you got two more, blah, 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 nucleophile, सामने से, पीछे से, either way, etc., etc. All right, you get a race pair mixture. Okay, and from actual experiments, you see that the inversion of configuration is more, the product is slightly more. Cool. Here's a quick question. SN1 reaction में अगर chiral center है, what is CH3 minus? I think the first option is bogus. Seriously? What's the first option you need? But I think this is, and I'm quite confident that this is a PYQ, which is why it is as it is. I haven't messed with this. Try and understand the question. ठीक है, first option weird है. SN1 reaction or chiral center, there is inversion more than attention leading to partial racemization, 100% inversion, 100% attention. This question is mainly to check if everyone's been awake, who's been watching this show. Yeah, watching this session so far. There's not much to it. This was in NEET 2015 if you want to know. 2015 NEET में पूछा गया था ये सवाल. I'm not making this up. You can look it up on any site you like. Yeah, seriously. Like, wait, what? What is this first option? Yeah, I felt the same thing. This is basically strong base. Okay, and we look at when we do E2 reactions, you'll see what I mean. इसका कहाँ पे use होता है? RO minus, right? R can be anything, alkyl group. Anyway, the answer to this one is B. Inversion more than attention. I just told you guys, please, you have to have got that right. Okay, cool. Here is an example of an SN1 reaction. Okay? Now, I've got ethanol and Ag+. This is just a catalyst. Okay? Silver. If you have done, when you study D block elements, you'll read a lot of them are used as catalysts. And depending on the kind of catalyst you use, you get different products. Yeah? Selectivity of catalysis. आपके syllabus से surface chemistry हटा दिया गया, but ये एक चीज थी. Okay? So go check it out on my last year sessions. Bento links में है, the ones that's already linked over here in the description and also pinned comment यहाँ पे. You can go check those out if you want. Okay, so this is the best example, one easy example of SN1 reaction. What's happening here? Okay, now in this case, this is fascinating, isn't it? मेरे पास ethanol है, but this doesn't cleave here. It cleaves here, which is weird, right? Do you see that? Did you see that? यहाँ पे kind of makes sense, doesn't it? Okay, think about it like this. If this is weirding you out, think about it like this. If I give you this sort of a question, right? यहाँ पे already it has 6 electrons. Yeah, like भाई दे दे ना, क्या problem है तेरे को? It gives me a couple of more electrons. Okay, so what I get here is this right here. ठीक है? Now, and I have a H in this case, and there is C, H, and there's a plus charge over here. Okay? Now, what happens यहाँ पे is something that's really fascinating. दो चीजें होती हैं. एक तो, pay attention here. एक तो हाइड्राइड ट्रांसफर होता है, which means कि बॉस यहाँ पे प्लस चार्ज है, मतलब empty ये पड़ा हुआ है. They're like, yeah, दे दे electrons and goes away. And what you get here is this awesome plus charge. ठीक है? Which is fascinating. So now you've got a tertiary carbocation. That is the first step, slow step. Okay. Now, what about the solvent? ये क्या हो रहा है? Solvent I've got is an alcohol, right? Methanol. Why is OCH3 getting added? Why not OH? OH क्यों नहीं add हो रहा है? Because if I were to break OH, I would get HBr. But if I were to break CH3OH, right? ऐसा है यहाँ पे. Now, if these electrons go here, which is what is actually happening, you get CH3O minus and you get H plus. Okay. And then this guy like, bro, attacks. Sorry, यहाँ पे नहीं, इधर attack कर दिया. Okay, great. And then HA plus and Br minus are happy and they form HBr. What about the other case? What about the other case? If I had this, if this were to happen, okay, theoretically, अगर ये होता, then I would get CH3 plus and OH minus. And that's weird because that doesn't happen. I'll tell you why it doesn't happen. Because this is a strong base. Okay, this is not a strong base. This is a weak acid and a weak base. And if you remember anything at all from the basis of organic chemistry, a reaction forms a weaker base and a weaker acid. That's organic chemistry 101. Is Are you able to follow कि ये क्यों हो रहा है? I found a lot of students mugging this sort of stuff. There is nothing to mug here. ठीक है? I'm going to write it in a different color. This is important. Yeah? Does not happen. Okay? Because weak giving you strong, not going to happen. But in this case, here it's cool, right? This is the reaction that makes sense. Is this okay? Any doubts on this so far? Friends, countrymen, let me know if this is cool. The main idea here is that this is one way to do it, right? Another way to do it is this. Pani dalo, AgNO3, catalyst, etc. And in this case, so if I want to form an, यहाँ पे एक चीज है मैंने बोला कि if I took methanol as a solvent and I got OCH3. Now what if I want to form alcohol? सिर्फ पानी डाल दो यार. You don't have to कोई पापड़ नहीं बेलना. This is very straightforward. Just put water and that's it. You get this as the product. Okay. And here you get a racemic mixture. Why did I get a racemic mixture? Because this is a chiral carbon. ठीक है, इसलिए दो बने हुए हैं. You'll be like ये दो चीजें क्यों लिखी हैं? इसमें क्या फर्क पड़ रहा है? This or this? This is 1 and 2. What is the difference here? Well, the order in which they are arranged. I'm just going to put random numbers to it. Okay, 1, 2, 3, 4. Well, random number भी हम लोग ऐसे डालते हैं, just for the heck of it. Okay, I'm giving these guys this number. Now, if I give these guys this number, 1, 2, 3, 4, you'll see that the order is different. Okay, order completely अलग है. And this is called a racemic mixture. ठीक है? Why? Because planar है, etc. etc. I've explained before already. So a quick recap of everything SN1 reactions is key. Step 1. The first thing, it is unimolecular. मतलब rate is proportional to what? Just the substrate. Is it just substrate or is it just a nucleophile or is it something else? Solvent, not nucleophile, right? The Rx itself. Okay. Reactivity, tertiary greater than secondary greater than, and also maybe a benzyl if I put here, benzyl इससे भी ज़्यादा हो जाएगा. ठीक है. Weak nucleophile is good. It's a two-step reaction. First step being the rate determining step. Yeah. Second step being the nucleophile attack. Okay. And you need a polar protic solvent like water or this, but not too strong. Yeah. Not too strong. And some cases, your solvent itself could work like a nucleophile. Yeah, those were the examples that I showed you. Okay, and it leads to racemization, but we say partial racemization, मतलब थोड़ा सा inversion. Yeah, inversion product is major. ठीक है, cool. So now here's a quick question. If I give you this sort of a reaction, what is the major product? Now आप SN1 लगाओ, SN2 लगाओ, कुछ भी लगाओ. You can do anything. Can you help me with that? Can you help me with this? Either way, yeah. SN1 low, SN2 low, do anything. It doesn't matter what you take. But I want you to tell me what is the major product of this reaction. Okay. So, oh, I already know what's going to happen. I've put water, right? Which is a polar protic solvent. So, SN2 is not going to happen. SN1 is likely. Let's see. होता है कि नहीं होता है. Let's see. Okay. So, if I were to form this, the सबसे आसान चीज ये होगी. This has electrons, takes 2 more. So, I should form a plus charge over here. And ये पानी भाई साहब यहाँ बैठे हुए हैं. So, if I were to draw water like this, like, hey, you know what? Let's form that bond. Hey, you know what? Another guy comes along, takes this away as H3O plus. What you're left with is this awesome, beautiful product. But I have a problem with this. Just like I started off, मैं आपको बताया था कि अगर कार्बोकैटायन बन रहा है तो सबसे स्टेबल कार्बोकैटायन बनेगा. अब देखो यहाँ पे I've got a secondary कार्बोकैटायन, but something that I told you earlier. What do you think could happen here? I showed you something called a hydride shift, and this one is a little rare. Okay, what I'm going to show you next is very rare. An entire methyl gets moved. You're like, wait, hold up. Methyl shift, really? Is that a thing? Are you making this up? Unfortunately, no, I'm not making this up. ठीक है, methyl shift होता है, and it is rarer than a hydride shift. Usually, between you and me, it's going to be mostly hydride shifts if at all they happen. मिथाइल शिफ्ट हमारे लेवल पे नहीं होता है, बट मे बी सम क्वेश्चन कहीं ना कहीं से आ गया, मिथाइल शिफ्ट हो रहा है. दिस इज एन एग्जांपल ऑफ सच अ क्वेश्चन. ओके, सो व्हाट इज अ मिथाइल शिफ्ट एनीवे? Well, look at it like this. This guy hops, skips, jumps, comes here. That's it. That's a methyl shift. और इसका hydrogen goes here. ठीक है? So essentially, you got a hydrogen here. This line just shows that this CH3. All these lines, by the way, just mean that there's CH3 groups over here. If you're not used to the line diagram, मैं इसी तरीके से लिखता हूँ. This is easier for me to understand. So this is the right answer, and I'm gonna go back here and what should I call it? Not this. उस वाले में लिख दें, so that you have a nice way to compare and contrast. Okay, so not this. This is the right answer here. So this is the most complicated quote unquote question that you could get from this topic. Okay, so इनमें से सबसे कम reactive कौन सा होगा in a nucleophilic substitution reaction? This is a slightly tough question. सबसे कम reactive कौन सा होगा? Now I'm not asking SN1, SN2, सब चीजें, everything we've learned so far can we apply in this question? सबसे कम reactive nucleophilic substitution reaction. Okay, so we're talking about substrate here. Okay, focus है substrate पे. Okay, so if I have a tertiary substrate, that goes via SN1. If I have a primary substrate that undergoes SN2. Okay, ठीक है, तो let's eliminate tertiary and primary. ये है tertiary और ये है primary. ठीक है, ये हट गया. Oh, what about this one? What about this? If this goes away, this gets a plus charge over here, which is awesome. This is great, isn't it? You've got like an empty unhybridized p orbital, etc., and this is basically a bunch of electrons, yeah, in the same plane as this. You're like, hey, great, let's resonate. So this is pretty stable. Okay, this is also going to be decently reactive. Yeah. अगर आपको याद है पहला सेशन ऑफ दिस होल बिजनेस ऑफ alkyl halides, I told you something about different types of cations. sp3 hybridized, sp2 hybridized. मैंने क्या बताया था? एनसीईआरटी में ही था, कोई बड़ी बात नहीं थी. उसमें समथिंग कॉल्ड एलाइल एंड विनाइल लिखा था. अब एलाइल क्या होता है, विनाइल क्या होता है, याद है क्या? बेसिकली दिस इज sp3 and this is sp2. This is weird. Putting a plus charge on this is bad. Okay, ठीक है? So this is called vinyl, this is called allyl. Since I always keep mixing up the names, I'm going to quickly look them up again. I'm quite confident of this, but एक बार check करने में क्या हर्ज होता है. Vinyl carbocation. But sp2 sp3 is what I have an easy way of remembering that. sp2 sp3 से क्या होता है. Yeah, that's right, this is vinyl, and this is not good. Putting a plus charge on something that is sp2, that's not very stable. So this is going to be the least reactive in a nucleophilic substitution reaction. When I say plus charge, now whether the charge gets formed और ये बॉन्ड टूटता है और दूसरा बॉन्ड बनता है, it's not possible, right? So कार्बोकेटायन नहीं बन रहा है. दूसरी चीज क्या नहीं हो रही है यार? For that I need sp3 carbon, तभी तो मेरा transition state बनेगा. For SN2 reactions, I need a transition state, yeah, which has like 5 bonds and all. वो तो नहीं हो रहा है. It's not going to get formed. Not going to happen even for that. ठीक है? So since no SN1, SN2, well, it's bad. It's bad for both. Okay? Slightly tough question. I told you, बड़ा मुश्किल है. I'll tell you what. I have a lot more questions for you. But in the interest of time, I'll go over and talk about elimination reactions first. And if time permits, we'll get back to solving more questions. And anyway, you know how the drill is, right? एक बार मैं पूरा chapter कर लूंगा, then I'll solve, go to the app, we'll practice as many questions as you like. We'll do that. Chalo, let's look at the next type of reaction, which are elimination reactions. And by now, I'm going to quickly open up the NCERT and show you what all we have covered so far, right? एक second. Hold up. NCERT F11. Okay, cool. So we have done SN1, which is unimolecular SN substitution, nucleophilic substitution reactions. And यहाँ पे they've made some nice, cool things over here to tell you that this works, this does not work. Oh, look at that. Beautiful, isn't it? Here you go. क्या है ये? This is allyl. बेंजाइल, दोनों की बात कर रहे हैं. Awesome. Both of these are stable because they have multiple structures that contribute to their stability. Chirality की बात यहाँ पे डिटेल में कर रहे हैं. We went over it quickly, but please read this. This is important. And this is sure. Dextrorotatory ये सब चीजें हैं. I've done stereochemistry last year. If you want to check those sessions out, you can do that. So this is technically covered, but please read the NCRT. And now we're going to go into retention. We've done all of this, inversion of configuration, etc., etc. All of this is awesome and done. Now we're going to move on to elimination reactions, and we're going to focus on E2 today because that's what's on the agenda. ठीक है? If you understood SN1, SN2, elimination भी समझना ज़्यादा मुश्किल नहीं होगा. ठीक है? We'll talk about elimination. What is elimination reaction? So elimination, as the name suggests, we're going to eliminate something. What will we eliminate? Let's eliminate one X, which is the halogen, and one hydrogen, which is, well, and if both of these go away, interesting. So H plus and X minus दोनों चले गए, तो बचा क्या? देखते हैं क्या बचा. Okay, so this is interesting. Two atoms or groups are removed from the substrate, generally resulting in the formation of a pi bond. Oh, pi bond. What is that about? Okay, let's see. So if this goes like this, this one goes like this. Okay. And this guy doesn't like having electrons. Like, you know what? I'm going to give those electrons and we're going to share them and hence form a pi bond right over here. Okay. You can think about it like this. You can think about it like this. This is maybe step one, and this is step 2. Something like that. ठीक है? So, and अगर ये ग्रुप अगल बगल से निकल रहे हैं basically, तब बन रहा है. ठीक है? Adjacent में जरूरी है. And because अगल बगल से निकल रहे हैं, you call it as 1, 2 elimination. 1 and 2 are basically positions. So you call this as 1, 2 elimination. You can also call it as alpha beta elimination. You may have heard of this term. कुछ books 1, 2 elimination लिखते हैं, कुछ लोग alpha beta लिखते हैं. ठीक है? अगर alkyl halide की बात कर रहे हो तो position 1 is going to be the one जहाँ पे X attached है या फिर position alpha, उसका बगल वाला beta हो जाता है. ठीक है? There are two types of beta elimination reactions. अब मैं अल्फा छोड़ दिया, बीटा ही की बात कर रहा हूं because X तो ऑब्वियसली निकल रहा है, उसके साथ बीटा मतलब कुछ निकलता है. ठीक है? Just like SN1, SN2, E2 and E1. You can guess this already. E2 क्या है? इसका ऑर्डर होगा 2. इसका ऑर्डर होगा 1. That's all. So आज we'll talk about E2 specifically. What is E2? ऑर्डर 2 होगा मतलब again will depend on substrate and nucleophile का concentrations. ठीक है? We'll talk about that. ओके, ठीक है. बट यहां पे समथिंग इज डिफरेंट. व्हाट इज डिफरेंट? यहां पे दो चीजें निकल रही है, तो यू नीड समथिंग स्ट्रॉन्ग टू टेक अवे टू एंटायर ग्रुप्स. सो वन सबसे जरूरी कंडीशन इज हीट. ओके, हाई टेम्परेचर मतलब रिएक्शन हैव फास्टर जनरली. एंड फॉर दिस स्पेसिफिक वन वी गोना टॉक अबाउट प्रोटॉन बीइंग रिमूव्ड बाय अ बेस. ओह लवली, दिस मेक्स सेंस. ठीक है, X माइनस तो अपने आप निकल जाता है, इट्स लाइक चिल. H क्यों निकलेगा? H तब निकलेगा अगर मैं बेस डालूं. ओह, that makes sense, right? If I have OH minus, it's going to pull away an H. So writing it, let me just show you. ठीक है? So elimination क्या हो रहा है? एक हाइड्रोजन का, दूसरा हैलोजन का. हैलोजन क्यों निकलेगा? Because I already did so. SN1, SN2 में आपने देखा. हाइड्रोजन क्यों निकलेगा? अगर मैं बहुत स्ट्रॉन्ग बेस डालूं और गर्म भी कर दूं. वेट अ मिनट, गर्म भी कर दें और स्ट्रॉन्ग बेस डालें? अच्छा, ठीक है, देखते हैं. स्ट्रॉन्ग बेस डालने की जरूरत है क्या? चलो देखते हैं. लेट्स ट्राई जस्ट हीटिंग इट. स्ट्रॉन्ग बेस बाद में डाल देंगे, देखेंगे. स्ट्रॉन्ग बेस डालने की जरूरत है क्या? विल सी. मे बी जस्ट बाय हीटिंग इट वर्क्स आउट. ओह ना, दिस इज प्रीटी स्ट्रॉन्ग बेस. ओके, सो इफ आई हैव ROH, इसका pH क्या है, और रादर pKa क्या है? डू यू नो दिस? व्हेन यू टॉक अबाउट ऑर्गेनिक केमिस्ट्री, let's take ethanol. Ethanol pKa. Let me tell you the values directly. 16. It's like, bro, that's like a very weak, very pKa मतलब वो H अगर निकाले तो कितनी आसानी से निकालेगा? It's not a very strong acid at all. It's pretty weak acid. And if you look at pH of ethanol, it's 5.4 to 7.5. So it can be both. Yeah, ethanol sample ka pH is this. We're going to focus on pKa values, okay? Because pKa values tell you how strong an acid is. Okay, so this is pretty weak. This is a pretty weak acid, which means its conjugate base is going to be stupidly strong. Okay, this is the idea. Okay, मैं बार-बार इसको repeat कर रहा हूँ. I've said this in my last session, the session before that, and every time I talk about this, students seem to miss this. But ये बनता कैसे? How do we make something like this? I'll tell you what you do. You take ROH, you make it react with a base. NaOH. Oh, that's interesting. So this makes it RO minus Na plus, and you get water. Like, wait a minute, ये क्या हुआ? हाँ, यही हुआ. So this is an acid. Sorry, this is the base and an acid, and this is the conjugate base of that acid. This is the conjugate acid of that base. ठीक है? अब ये तो हम लोग ionic equilibrium कर रहे हैं क्या? हाँ, क्यों नहीं? Ionic equilibrium is the heart of organic chemistry. Without doing ionic equilibrium, you cannot do organic chemistry. You should not. करने का तो कुछ भी कर सकते हो, but you should not. ठीक है? Okay. So this is beautiful. Now, why did I do all this राम कहानी? Because once you have this RO minus, ये भाई साहब इसके हाइड्रोजन को आसानी से निकाल लेंगे. किसके हाइड्रोजन को? या तो ये हाइड्रोजन या तो ये हाइड्रोजन is going to attack either this or this. ठीक है? That is what is being formed over here. So you get alpha beta elimination, which is this, and you get ethanol. वही तो है, बताया था आपको. बन रहा है फिर से वापस यही रिएक्शन हो रहा है, and you have Br minus poor guy hanging around. Okay, so इसी को हम लोग बोलते हैं hot alcoholic solution of KOH or ETO minus and ETOH. It's the same thing. KOH, NaOH, you usually use KOH. मैंने NaOH लिख दिया था. ठीक है? So hot मतलब heat, or you use NaNH2, strong base as well. भारत का कल, आप है भारत के कल, आपके लिए तो ये सब एनर्जी हो रही है. खैर, so this is it. I've given you as much information as you possibly need. हम लोगों ने सबस्ट्रेट की बात की, सॉल्वेंट की बात की, और न्यूक्लियोफाइल की बात नहीं की. न्यूक्लियोफाइल की भी बात कर लेंगे. मैकेनिज्म क्या होता है? मैकेनिज्म, ब्रॉड आइडिया ये है, ठीक है, कि ये बेस आया. बेस कौन सा? स्ट्रॉन्ग बेस. स्ट्रॉन्ग बेस आया. स्ट्रॉन्ग बेस आके हाइड्रोजन को निकाला. I already shown this to you, right? One step was this, and the next step, well, same transition state की वजह से ये दूसरा स्टेप बन जाता है. ठीक है? This is similar to, hey, transition state. This is similar to SN2. Yeah, absolutely. Transition state similar. ठीक है? So now I only care about this, the substrate. Substrate की concentration में all I care about. इसीलिए, no, hold on. We care about this and the nucleo and the base concentration. राइट, बिकॉज ये 2 लिखा है ना, E2 लिखा है, मतलब हम दोनों के बारे में केयर करते हैं. इफ यू केयर अबाउट बोथ, मतलब यही हो रहा है. इफ यू वांट टू लुक एट द ओवरऑल, बहुत अगर थोड़ा डिटेल में जानना चाहते हो बेस और आरएक्स के साथ, दिस इज द ओवरऑल मैकेनिज्म. नॉट नेसेसरी, बट आई हैव ऑलरेडी शोन इट यू शॉर्ट में. उसको मैं डिटेल में वही चीज दिखा रहा हूं आपको. ठीक है? इफ यू हैव एनी डाउट्स इन दिस, आस्क मी. इट्स नॉट रेलेवेंट टू योर एग्जाम्स, बट इट्स इंपॉर्टेंट टू लुक एट रिएक्शन मैकेनिज्म, ताकि ऑर्गेनिक केमिस्ट्री ठीक से समझ में आए. मैं भी सीख के आपको पढ़ा रहा हूँ. ठीक है? This is how it works. Cool. And I also told you how this strong base gets formed. The solution, NaOH plus ROH. ठीक है? Single step bimolecular reaction, second order reaction, and rate proportional to Rx, which is substrate, and base का concentration. ठीक है? Rearrangement is not possible because we are not giving enough time. This is also kinetically limited, just like SN2 reactions. मतलब E1 होगा कुछ, हाँ, E1 is going to be thermodynamically limited, मतलब वहां कार्बोकैटायन बनेगा, यहां नहीं बन रहा है. Okay, this is pretty interesting. This last step is extra, like way extra. ठीक है? The orientation of proton and leaving group should be anti. अब ये, what are you talking about? Okay, I have something here, I have something here, something here. Let's say this is here, this is here. This is an anti position. ठीक है? This is the sin position. Sin मतलब not Bible वाला sin. Yeah, this is sin. Let me draw it properly. Let's say, let's put X over here, let's put H over here. Let's put X and H. This is sin, this is anti. ठीक है? मतलब opposite sides, yeah, that's all anti means. This is because of the reaction mechanism. Okay? Beta hydrogen is eliminated by the base, hence it is called as beta elimination reaction. Lastly, अगर एक से ज्यादा elimination product possible है, तब we use something called the Sivzev rule. ये, this is the Russian name. ठीक है. If you want to look it up, yeah, Russian is fun to learn. A lot of amazing scientists are Russian, Mendeleev, Sedzev, etc., etc. But he moved to Germany, so they write his name two different ways. Yeah, either with this way or this way as well. दोनों तरीके से लिखते हैं. Sedzev rule दोनों तरफ से होता है. The other option, by the way, this is the more substituted carbon पे बन रहा है. This is the less substituted, called also known as the Hoffman product. ठीक है? There are two possibilities as you can see. If this is getting a little bit too crowded, मैं quickly इसको बता देता हूँ यहाँ क्या हो रहा है. Base या तो more substituted carbon पे अटैक कर सकता है, हाइड्रोजन. More substituted carbon, hydrogen of more substituted carbon, or hydrogen of less substituted carbon. ठीक है? So why would the base do one or the other? Well, it depends on some other reagent. अगर आप कोई चीज ऐसी डालो, अगर आप कोई ऐसी चीज डालो जिसकी वजह से भाई यहाँ पे होगा वहां पे होगा, yeah, you have to think about these things. You can affect this sort of change to happen. ठीक है? अगर base sterically hindered है, मतलब कि base बड़ा है, sterically hindered मतलब you have a big base, then it will be like कि you know what, I'm good, I'll do the Hoffman product. Base sterically hindered. इसका क्या मतलब हुआ, अंग्रेजी का क्या मतलब हुआ? अगर if it's a big base, although it wants to do this, someone else like, you know, I'm not doing that, I'd rather just do that. Okay, so Hoffman product is usually by a sterically hindered base. Cool. और अगर दो से ज्यादा बीटा कार्बन हो जाते हैं, then you figure out hyperconjugation which is a better product. Okay, this is called a Sedzev product, this is called the Hoffman product. Also, agar as usual, if I have Ri, RBr, RCl, RF, Ri is the best always. Rate of E2 reaction, tertiary. Hey, hold on a minute. This is different from SN2. इसलिए मैं लिख रहा हूं. क्यों लिख रहा हूं? Because you will most likely in life and exams also, you'll have to figure out, is it going to be SN1, SN2, E1 या E2? This is what you have to figure out. इन चारों में से कौन सा होगा? So, rate of this E2 reaction, tertiary alkyl halide, best. क्यों? क्योंकि देखा ना यार, अगर हाइड्रोजन निकल रहा है तो अच्छा है ना. That is what you want, because the hydrogen is coming out from the beta position, not from the alpha position. देखो, this is not different from SN2, although it looks like. SN2 में क्या हो रहा था? हम लोग X निकाल रहे थे from primary, but we are talking about hydrogen निकालना. Why is it this, by the way? Hydrogen removal from beta carbon, and hence you call it beta hydrogen elimination, right? You see that? थोड़ी डिटेल की बात है. हम लोग अल्फा पोजीशन में X की बात नहीं कर रहे, उसके बगल वाले बात करें. तो बगल वाला अगर टर्शियरी है तो अच्छी बात है. That is what we are talking about here. Cool. All right. What are the factors that affect the rate of this E2 reaction? We'll quickly go over this. I've explained all of it already, but we'll just put it in one place. So, I have no idea, dude. Jay, Yadvanshi, आप जो मेरे से पूछ रहे हैं, I have no idea about this. I'm responding, but I don't know. मालूम होता तो बता देता ना. All right, Bharat, thank you for responding and telling this guy. I've already told you nature of alkyl halide, tertiary better than secondary, greater than primary. Yeah, that's already done. Next part is nature of base. If you have a strong base, best. Strong base is really good for this because abstraction of proton is easy. Let's say hydrogen, not proton. ठीक है, hydrogen is easy. Proton ही निकलता है, but ठीक है, hydrogen. And this depends on the concentration of the base. दो चीजें. Nature of solvent. अब देखो यार, solvent का क्या है कि depends on आपका base कौन सा है, in a way, right? दोनों related हैं. In this case, they are both related. They're clearly related. I told you कि solvent क्या होगा? अगर ETO minus लोगे तो ETOH लोगे. Makes sense, right? To do that. So I take ethanol and I add some, say, KOH to it. That basically gives me this. ठीक है, depends on the reagent taken. Leaving group ability, देख चुके आप already. I is greater than Br is greater than Cl, greater than F. Woo! So this is summarizing everything on E2 reactions. Bimolecular, rate depends on substrate and the base concentration. Base has to be strong, and this is a one-step reaction. हाई टेम्परेचर, प्लीज डोंट फॉरगेट दिस। बहुत बार स्टूडेंट्स ये चीज भूल जाते हैं कि you need to heat it. Only then this reaction is possible. Now, if you have all other things but heat nahi hai, then it's unlikely that this will happen. And solvent depends on the reagent. Transition stated just like SN2, right? Write that properly. Hold on. Just like SN2. And it generally follows Sidzev rule. But if you have sterically hindered base, then you get the Hoffman product. अब ये Hoffman क्या है, क्यों है, थोड़ा पढ़ लेना. Why do you call it Hoffman? Read up. Okay, not in your syllabus, but I'm telling you extra stuff anyway. भारत का कल, मैं बैंगलोर से क्लास ले रहा हूँ. Also BYJU'S bro, that's like the channel and all. I'm at my home right now. All right, thank you everybody for your time. That was it from me. मैं आपसे मिलता रहूँगा. I've got a couple of more sessions going for this. We've done 4. We'll do a couple of more sessions. And I did this last year as well. The main difference is that this year I'm spending a lot more time on theory. Questions हम लोग करेंगे साथ में. But I'm doing the theory inside out. Last time also I did so. But the feedback that I got was कि यार, you want more detail. You don't want just what's in the NCERT. You want more detail. And that's what I've come with you this time. That's how these sessions are different from last year. If you're impatient, you want to check out last year's sessions, वो भी है यहाँ पे. That has a few more questions in every session that's solved. The duration is the same. If you want to solve questions at the end of the chapter, we will do that. हम लोग करेंगे, ठीक है? We'll open the BYJU'S app. We will practice as many questions as possible. You can do it now also. It's completely free. ठीक है? चलो, I'll see you around. Thank you everybody for your time. Watching it live, not watching live, जैसे भी देख रहे हो. Share this with your friends if you liked it. Okay, bye. मिलते रहेंगे. I took the session on Sunday today. थोड़ा सा routine this week का थोड़ा अजीब हो गया. I'll get back to Tuesday, Thursday, Saturday, and all of that, Monday, Friday type routine. I don't think I'll be doing Sunday classes very often though. Thank you all for sticking around. See you all. Bye. Tata. Thank you.